Solve the cubic equation. We have the equation 2x cubed minus 5x squared minus 9x plus 18 equals 0. I like this problem because this solution encapsulates a lot of what we've gone over in pre-calculus this year, and I've supposed for Algebra 2 and other algebra-related courses as well. So we have this function 2x cubed minus 5x squared minus 9x plus 18 equals 0, this equation, and we can solve this equation and find the solutions by graphing. If we change that 0 to an f of x, and change this to f of x equals 2x cubed minus 5x squared minus 9x plus 18, and when we graph this function, we will see where the function touches or crosses the x-axis, which will give us our solutions to this. But I'm going to focus in on the analytical process today and use different theorems to solve this equation. And the first thing we're going to look at is we're going to look for possible rational roots. And so for that, I'm going to avail myself of something called the rational roots theorem. And sometimes you can call it rational zeros theorem. And what it is the possible rational roots or rational zeros okay, what are they equal to? They're going to be equal to plus or minus factors of last term over factors of coefficients the first term. Of first term. So in this case, in the case of our equation here, we will have plus or minus factors of 18, which is our last term. So that's going to be plus or minus 1, comma, 2 is a factor, 3, 6, 9, and 18. And then in the denominator, we're going to have 2, because that's a coefficient of the first term, 2, so 1 and 2. And so our possible rational roots for this are going to be 1 over 1, so plus or minus 1 over 1, which is 1, plus or minus 1 over 2, so we're just going down the list here. And now we're going to take 2 over 1, which simplifies to plus or minus 2, and then 2 over 2, well, we're already represented with 1 here, so we don't have to do any more there. Then we have 3 over 1, which is going to be plus or minus 3, and then 3 over 2, so plus or minus 3 over 2. Next we have 6 over 1, which simplifies to plus or minus 6. And then we have plus or minus 6 over 2, which already simplifies to plus or minus 3, which is already represented. Then we have plus or minus 9 over 1, which is plus or minus 9. Then plus or minus 9 over 2, which can be plus or minus 9 over 2. And then we have plus or minus 18 over 1, which is plus or minus 18. And then we have plus or minus 18 over 2, which is plus or minus 9. We've already represented that. So this set here, plus or minus all these, represents our potential or possible rational zeros. Now really that's quite a number, isn't it? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 2, 18 possible rational zeros, and we only can have at maximum 3 different unique solutions here. So we have more than what we need to work with here. We know that in this list, if there are rational zeros, we're going to find them there. So now we're going to go test the zeros. And for that, now you can start using synthetic division right now, but what I'm going to do is use something called the remainder and factor theorem. Remainder and factor theorem, they're really, sometimes you'll see them separated, but they're really different sides of the same coin, essentially. So what you're looking for is the remainder, and if you have a zero, the factor theorem is that if you have a zero and plug that zero into the function, you will get zero as a remainder. Or if it's not a zero, you will get something other than zero as a remainder. So we're going to go ahead and test the easier ones. And what is the best way to do this, I found, is take the smaller numbers and not the fractions initially. You may come up with a fraction as a zero, but the analysis part will be better served by taking your smaller numbers plus and minus, usually plus or minus 1. So the first thing we're going to do is test for zeros. And typically what we do for a cubic function, if we find 1, then we have an easier time factoring or otherwise analyzing what we have left. So we're going to test x equals 1 as a 0. So to do that, we're going to take f of 1, and that's going to be just an easier one we have out here. F of 1 equals 2 times 1 cubed minus 5 times 1 squared minus 9 times 1 plus 18. And simplifying out, we have 2 times 3 cubed is 2 minus 5 minus 9 and plus 18. And simplifying out, we have 2 minus 5 is negative 3, minus 9 is negative 12, negative 12 plus 18 is 6. So since f of 1, let me write that down here. Since f of 1 is not equal to 0, one is not a 0, and also the factor x minus 1 is not a factor of the function. And we'll get into that later. Now we're going to test x equals negative 1. Okay, so f of negative 1, so same sort of process. We're going to say 2 times negative 1 cubed minus 5 times negative 1 squared minus 9 times negative 1 plus 18. And we're going to go ahead and simplify that. 2 times negative 1 cubed, that's negative 2. And then we'll have minus 5 here. And then minus 9 times negative 1, that's going to be plus 9. And then we're going to have plus 18. Now, negative 2 minus 5 is negative 7, plus 9 is 2, plus 18 is 20. Okay, same process is f of negative 1 is not equal to 0, so negative 1 is not a 0, and the x plus 1 is not a factor of the function. So I hope you can see how a factor and remainder are related here. Next we're going to try 2, so I'll say test x equals 2, and we're going to plug in f of 2 is equal to 2 times 2 cubed minus 5 times 2 squared minus 9 times 2 plus 18. Well, already I can see that this 9 times 2 is going to be negative 18 plus 18, so those will cancel. So what we have is 2 times 2 cubed. That's going to be 2 times 2 cubed is 8 times 2 is going to be 16. And then we have minus 5 times 2 squared is 4, so minus 20. 20 is equal to negative 4. Okay, so f of 2 is not equal to 0. Therefore, 2 is not a 0. And x minus 2 is not a factor. Now we're going to test x equals negative 2. So f of negative 2 is going to be 2 times negative 2 cubed minus 5 times negative 2 squared minus 9 times negative 2 plus 18. And then we have negative 2 cubed is going to be negative 8 times 2 will be negative 16. And then negative 2 squared is 4 times 5 is going to be minus 20. And then we're going to have over here negative 9 times negative 2 is going to be plus 18. And then this plus 18 over here. So what we have here is negative 36 plus 36, and that's equal to 0. So we know that x equals negative 2 is 0, and we know that x plus 2 is a factor. So now I'm going to go do a synthetic division, and x equals negative 2 is a 0. So here I put negative 2, and then we're going to synthetically divide this equation. So I put the coefficients 2x cubed minus 5x squared minus 9x plus 18. And then we bring down this 2 here. So we're going to get 2x squared. Negative 2 times 2 is negative 4. Negative 5 plus negative 4 is negative 9. Negative 2 times negative 9 is going to be 18. Negative 9 plus 18 is 9. Negative 2 times 9 is negative 18. So we have 0. And what we have left here is 2x squared minus 9x plus 9. And so we know that this function factored, this equation factored, is going to be quantity x plus 2 times quantity 2x squared minus 9x plus 9. And we can set this equal to 0. And now if we can factor this 2x squared minus 9x minus plus 9, well, to do this, we have a little bit of a complication here. I mean, we don't have 1x squared. But I use what I call an X method or bottoms-up method for slightly more complicated things. So we have A is equal to 2, B is equal to negative 9, C is equal to 9. So up here, on top of the x, we have AC, which is 2 times 9, or 18, and then we put b down here at the bottom, or -9. So what two numbers do you multiply by each other, yet that one to equal 18, but when added together equal -9? Well, I think for that we should get -6 and -3. Is that right? Yeah, that's right. And then we put over a, and what is the value of a? Well, 2. So what we have is, on the left side, -6 over 2 simplifies to -3, and the right side, -3 over 2, do not simplify. So what we have is, we have x minus 3 and times quantity x minus 3 halves. And using the bottoms up method, we take this 2 up here, so we have quantity x minus 3 times quantity 2x minus 3. And now the zeros, we can use the zero factor property and set this section equal to 0. So using the zero factor property, x minus 3 is equal to 0, and also 2x minus 3 is equal to 0. And if we solve this left one for x, we add 3 to both sides. We have x is equal to 3, and over here on the right one we add 3, so we get, that's 3 over there, a little more legibly, it's not too legible. All right, then we have 2x is equal to 3, and dividing by 2, we have x is equal to 3 over 2. So to summarize, our rational zeros, and they're all real zeros, are x equals -2, which is the first one we found using the remainder and factor theorem. We have x equals 3 over 2, and we also have x equals 3. So here they are. And again, I like this because it encapsulates a lot of what we've been doing. And I'm going to go lastly and graphically analyze this. And so I previously entered this function here in my T-inspired CX calculator. I press enter, and I hope you can see that the zeros are -2, and we have this one between x equals 1 and x equals 2. That's going to be 3 over 2. And we have also x equals 3. So good luck with this and other problems you're going to be working. And as always, thanks for viewing.